Okay, today we're going to start our permutations and combinations counting principles unit. Okay, it's something that you will have never seen in math before, so this is all going to be very new to you. Okay, so a combination, you have this thing on your formula sheet right here. These two things in this side of your formula sheet, so this will be on your exam. This is exact paper that I give you on your exam. Obviously, I think I've told you this over and over again, though, you don't get the back side of this. This is all my stuff, the unit circle. You do not get that. But so on the exam formula sheet, here we go. The combination is obviously the one that's got a C in it, and the permutation is the P one. So I'm just going to copy these down. You have no idea what this even means. Okay, so that's where I got them from, was the formula sheet. Okay, so combination versus a permutation, what's going to be the difference? In a combination, the order doesn't matter, and in a permutation, the order of something matters. So some examples would be, a combination would be pizza. So if you could pick 2 toppings for your pizza out of 4 options, that's a combination, because it doesn't really matter the order. Like, you never call a pizza place and say, can I have ham and then the pineapple? You just say ham and pineapple. It doesn't, you don't say, I need the pineapple on the bottom and the ham on the top, whatever, right? It doesn't really matter. You just say the combination. A permutation, the order matters. So something like a ball lineup, a batting order. Does it matter the order that I'm putting my players in? For sure. Can I change that? Yeah. I could take the same 9 people, but I can make different arrangements of that batting lineup. Okay, so permutations, the order, changing position matters. Combinations, it doesn't. Okay, so you're also going to see this new crazy thing with an exclamation mark. This is called a factorial in math. So what does 4 factorial mean? It means 4 times 3 times 2 times 1. That's what it means. So we can do this one in our head. What's 4 times 3? 12. 12 times 2 is 24. Okay, so let's jump to our calculators. I'm going to find that button. 4, and then mine is right here, the N with the exclamation point, and I can push that in and get 24. So see if you can find that button on your calculator. Okay, so 7 factorial, so what do you think that would mean? That would mean doing a 7 times 6, 5, 4, 3, 2, 1. Okay, so again, let's go to that button in our calculator. So 7 factorial equals, let's see if you can get to that answer using your buttons. Okay, so we're often going to see something like this, NPR. So N is the total object options and then R is going to be the number selected. Okay, can anybody tell me why this would make a math error? How can you choose 9 when you only have 7 total? Okay, so explaining that might be a test or exam question where you have to actually explain it with a sentence. So you could say something like, you can't select more than you even have in total, right? That doesn't make sense. Okay, so I'm just going to get you to take a minute to look at what I'm going to do. Okay, so I'm going to have 3 markers here, and I want to think about how many combos can I have. So I have 3, and I'm going to be able to pick 2. Okay, so give me one of the options I can choose. So I'm going to give, like Reese, here's 2 markers. Okay, what could I do? What could I give him? Give me something. Okay, so yellow, blue. That was 1, right? Okay, something else. What could I do? Pink and blue. I could do that, right? That's another combo. Something else. Yellow and pink. And then that's it. Okay, so I'm going to get you to type this in your calculator. You're going to go 3 and then find your C button and then push a 2. So it needs to look like this in your calculator. 3 objects, and we're trying to make a combination with 2 of them. And then it should equal 3, right? Because we just showed the options. Okay, did everybody find that button? Yours is in that same list. Okay, so now we're going to talk about permutations. So I'm going to keep the 3 markers, and I'm going to permutate with 2 of them. Okay, so I'm going to hand 2 pens over, but I could do like this. I could give a yellow and a blue one, a yellow and then a blue one. Guess what I could also do though? I could also switch that up, and I could give somebody a blue and a yellow one. So I'm changing the order because the order is mattering. Then, what else could I do? I could go with a pink followed with a yellow, or I could switch that and do the yellow and then the pink. And then what else we got? We got blue and pink. So I could do blue, pink, or I could do a pink and a blue. I could change the order of that. So this should be 6, right? So let's check that out. So I'm going to go 3 and then find the P button. So that's shift 6 on mine. And we should get to 6, right? So do you see the difference between a permutation and a combination? I didn't care about the order of the 2 objects, but here I did. So I could make some switches. Okay, so I kind of just broke that down on your paper with just an example of library books. So the same thing. There was 5 books to choose from, and I needed to pick 2. So here's all my combinations. But then when I did permutations of those 2, I could pick 1, 2, or 2, 1. Versus here, you can see that if I pick 1, 2, picking 2 and 1 isn't something different in a combination. Okay, so how do you use those little formulas? Okay, so at the top here, we had these formulas. So n factorial divided by r factorial, n minus r factorial. Okay, so n factorial, so remember what this is. This is the number of objects, and r is the selected number. So n is always the total number, r is the selected number. So 5 factorial divided by 2 factorial, and then n minus r, so what do you get when you do 5 minus 2, which is a 3 factorial. Okay, so here's what I'm going to do. I'm going to not use my calculator, actually. 5, 4, 3, 2, 1. That's 5 factorial. Two factorial is 2 times 1. 3 factorial is 3 times 2 times 1. I'm going to do this. 3, 2, 1 cancels a 3, 2, 1. So what is 20 divided by 2? 10. Okay, so 5 choose 2, I'm just checking, is 10. That's how we got there. Okay, and the permutation formula is just this one. So n factorial would be a 5 factorial. And then the subtraction, so 5 subtract 2 is 3 factorial. So if I expand those, 5 factorial is 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. I get 20. Okay, and there should be more permutations and combinations, right? Because the permutations added in all the switches of the orders. Okay, using the formulas, prove that these are equal to each other. So the formula would go 15 factorial over 2 factorial. And then this one is the subtraction. So what's 15 minus 2? So 13 factorial. On this side, 15 factorial over 13 factorial times the subtraction. So what's 15 minus 13? 2. And are those going to be the exact same values? So what can you conclude? So if I ever did something like this, 16 choose 3, that should be the same thing as 16 choose 13. Whatever numbers make 16 together, the subtractions. 16 minus 3 is 13, so then it'd also be the same. Okay, so what would this be the same? What would I need in this spot to make those the same? Think about the pattern. What was going on with those numbers? I would need a 10. What are these two numbers doing? 2 and 13. They're adding to 15. Okay, one more, because I'm not sure if you're quite getting it. What would be the number here to make this the same? 14. Okay, calculate the number of ways you can arrange 3 people on 3 chairs. Okay, I'm going to show you 2 different ways to do this. Okay, so if you are, there's my chairs. Okay, I'm going to put somebody on my first chair. How many options of people would I be able to put on my first chair? I have 3 options for people. Okay, now visualize that person, they're sitting down. How many options do I have to put somebody onto my second chair? I only have 2 options now, and now they're sitting. So then what's the options for my last chair? 1 person, and I'm going to times these, so then I get 6. Okay, I'm also going to do this as another method. I had 3 chairs, 3 people. Am I making a combination or am I making a permutation? So, in other words, does the order matter or not matter? The order of the people on the chair matters. So that would be a permutation. Same thing. Okay, so calculating the arrangements, 3 people on 2 chairs. So there is my 2 chairs. How many options would I have for people to go on my first chair? I have 3 options. How many options onto my second chair? 2 options. So I end up with 6 again. Okay, the other way you could have done this was a 3P2, because you have 3 things and moving around 2. Okay, calculate the number of ways to arrange 8 people on 3 chairs. So these are my 3 chairs. How many options do I have for people on my first chair? I could have 8 different people on that chair, or 8 options to pick from. Then I would only have 7 options on that spot and 6 on that spot. Okay, and then this is also the same thing, 8P3, because you're moving around 3 different positions. Okay, simplifying this, so factorials. When you're working with factorials, you always want to work with the bigger one. So I'm going to go 91 and then times 90 times 89 times 88 times, like this would just keep going, right? So this one would be 89, 88, oh, it would just keep going. So then can you see that all of this multiplying and all of this would just cancel? Okay, so my way of doing this is just I expand the bigger one until I match, like that. This is how I would write it. I expand until I match something, and then I'm going to show you that this and beyond would cancel this and beyond. Okay, so I'm going to type 91 times 90 in my calculator. So if you think that you can just type that into your calculator, you would never be able to type like the original. You wouldn't be able to type that into your calculator. It won't do it. Okay, so here's me trying to type that into my calculator, 91 factorial divided by 89 factorial. Okay, why doesn't my calculator do it? It's just too big. Your calculator can't handle that number. Can you imagine 91 times 90 times 89 times 88, like how big that number would be? It's massive. Okay, you're gonna make an outfit for yourself, and you have 4 shoes, 10 shirts, and 8 pants to pick from. Okay, so I have 4 shoes, and I'm gonna need a pair of shoes, just one pair of shoes. So would I choose that shoe, or would I permutate with that shoe? I'm just gonna choose that shoe. The order of my shoes don't matter. I'm just gonna be choosing one of them. And I have 10 shirts, and I need to choose one of them. And then I have 8 pants, and I'm going to have to choose one of them. Okay, now, if you wanted to, you could try this 4 choose 1 in your calculator, but I'm going to tell you it's just the number 4. 10 and 8. So you might see that question with making sandwiches or pizzas or something like that as well, where I might say there's 10 types of bread and you have to pick one, and then there's 3 types of meat and you have to pick 2, and there's something like that. Okay, we're going to make committees with students. So how many committees of 3 can you choose from with 10 students? So if I have 10 students and I need a committee of 3, my question is, what kind of letter would I put there? So on this committee, does the order of these people matter, or am I just trying to make a group? I'm just trying to make a group of 3 people. I don't need to change their order around. Okay, you have 7 boys, 5 girls, and you want to make a committee of 4. If you had no restrictions, how many possibles would you have? Okay, well, on this one, if there's no restrictions, I just take how many people options do I have? 12. I need 4. And then I'm thinking, do I have to worry about the order of these people? No. Okay, 3 boys and 1 girl are on this committee, so I'm going to just go a little bit separate here, boys, girls. Let's talk separately here. So I need 3 boys on the committee, so talk to me about how many options you would have. 7, and you need to choose 3 of those. For the girls, you have 5 girl options, and you need to choose 1. Now, I need to think about what kind of math connects these. So, would you multiply or add? you're going to multiply. Okay, in math, when you think I'm doing this and this at the same time, that's a multiply situation. Okay, you need at least 2 boys. Okay, at least. That is a word that we have to pay attention to. At least 2 boys. So what does that mean to you? You need that, or you could be more than that yet, right? So let's say we could have 2 boys on this, and that would be fine. Or we would be allowed to have 3 boys, because we're at least, or more. Or we could put 4 boys on this committee. Okay, so if there was the situation where I was putting 2 boys on there, I would need 2 girls as well. If I was to put 3 boys on there, I would need 1 girl on there yet. And if I was to do 4 boys, I wouldn't need any girls. Okay, so here we go. 2 boys, 2 girls. So 7 choose 2. So that's how many boys there were, and I'm going to pick 2 of them. And there's 5 girls, and I'm going to choose 2 of them. The word or is a separate situation, so I'm going to add it. So the word and, you multiply. The word or means to add. So this one I'm just going to copy down from above, because that's the one we just did. So I already knew what that one was all about. Or, so another add sign. 7 choose 4. So that's how many boys. And then 5 choose 0. Or you don't even have to technically write that if you don't want to write it as well, because the value of that is just going to be 1. Okay, Alec or Kristen are on a committee, but not both of them. So we're going to have a committee where we're either putting Alec on it or Kristen on it, but we can't have a committee where both of them are off. That's not allowed, because one of them has to be on. And we also can't have a committee where they're both on. So there are 4 kind of scenarios here where Alec is on but Kristen is off. Kristen is on, Alec is off. They're either both on or both off. Okay, but I don't want those. I only want these possible scenarios. Okay, so if Alec is on, that's Alec, choose Alec. So I need to put 3 boys on this committee. All right, I already have Alec on there, so I already have a boy on there. So I still need 2 more boys, right? So still need to choose 2 more boys, but how many options do I have available for the boys? I don't have 7 anymore, because why? Because Alec is already on this committee, so he's not an option anymore. So 6. Okay, I also need to choose a girl to put on this committee. And I'm not allowed to pick Kristen. I'm not allowed to pick Kristen, so how many options for girls do I have available? Did you write 4? Does that make sense? Because Alec isn't an option anymore. Kristen isn't an option for the picks, the available selection. Or another scenario, so I add, so this is all happening at one scenario, so that's why it was multiplied together. This is an or situation separate, so I'm adding it. So if Kristen is on, there's Kristen, choose Kristen. Okay, I need to pick 3 boys yet to put on this committee. But remember, Alec isn't allowed to be on this one. So now I have just 6 available options. Okay, so there's my 1 girl, my 3 boys. So that committee would be good. Okay, arranging letters. Okay, just simply, if I had something like this, the word dad, and I could rearrange the letters. So if I moved this letter there and this letter there, it would still look like that. It's still the same. So when you move around letters, and they're repeated letters, this is 2 different arrangements, but they look the same. So in math, when you want to cancel something, you divide, right? In math, when you want to cancel something out, you divide it out. Okay, so how many letters could I rearrange here? Count how many letters you have. I think I'm counting 11. Okay, so I'm going to move around 11 letters in different positions. I can do a factorial on that. But if I move around that S and that S and that S, it doesn't really change anything, so I'm going to cancel those options. So I have 4 S's. I have 4, I believe, right? I's. And I have 2 P's. Okay, so move around things, but then because there's repetition in there, we're going to cancel. Okay, what is wrong with this on my calculator? If somebody typed this in, they're going to get it wrong. Why? What would I do to fix that type? Because this is going to come out wrong as soon as you type it. That's how you fix it. Okay? So that's a very common mistake. 25% of students get this question wrong because they forget that they're doing a bracket situation. check it out. Did we match? Okay, I'm gonna hopefully